Okay. Didn't ask you.
So I left my homework.
Well, then get it done. Redo it real quickly. You can do this. Just get it done. All right. Hey, let's focus, please. All right. Any questions on the homework? Questions on the homework, which was greatest common factor. Greatest common factor. Nothing? That's a good thing. Well, either means no one did their homework or everyone did it and there's no questions. All right. Yesterday's class, listen please. Listen. Yesterday's class, I made a statement. I said that you guys are not listening. Yesterday's class, I made the statement. Usually the first class goes well. There's no problems. It's the second class because it's so like the first class. Like today we're going to do this thing called LCM, least common multiple. And it's nearly identical to what we did, except it has different rules. And so what happens is students mix the two up. What's going to save your bacon, right? Save your butt from making mistakes is the test is Monday. Yeah, Monday. What will save you is that you have a solid example on your resource card of both GCF and LCM, so that you don't mix the two up. Okay. But yeah, typically after the first day, I don't have too many questions. You had a question? Somebody? I thought somebody had their hand up. Let's take a look at number 8. Number 8. Number 8 says the following. It says, find the GCF of 75 and 1 set large numbers. 75 and 175. So 75 and 175. What was your preferred method? Brute force or prime factorization? What? List all the factors. Okay. So we got to start with 1. 1 and 75. 2 doesn't go to its odd. 3 goes to 7 plus 5 is 12. So 3 goes into 75. 3 times 1 is 75. That would be 25. 4 doesn't because it's odd. 5 goes into it. 5 times, let's see, 1, is it 15? Is that right? Yep, 15. 6 doesn't. 7 going to 75? No, it goes to 77. 8's even.
Excuse me?
Yes, ma'am.
No, Amelia.
Neil, is on his way.
Thank you.
What would we leave off on? 8. 9. 9 doesn't go into it. 10, no. 11. We're out of numbers. So there's your brute force factorization of 75. Okay, we got to do the same thing with 175. So this is when you get the large numbers are really large. Maybe prime factorization makes it a little bit easier. Let's see, 1 and 175. Not 2. 3. Let's see, 7 plus 1 is 8 plus 5 is 13. So 3 doesn't go into 13. 4. No, it's odd. 5. Yep, 5 times. Somebody? 30.
33.
35. Is it 35 or 33?
35.
35. Let's see. 5 times 5 is 25, 32, 15. Yep, 5, 35. 6. No. 7. 7 goes in 17 twice. 14. Oh yeah, 7 does. What? 20. 25. Is that right? I think so. Because 825s would be 200. Yep. Yeah. 8 does it. 9. 1 plus 8. 7 is 8 plus 13. 9 doesn't go into 13. 10 doesn't go. 11 doesn't go. 12 doesn't go. Wow, this is kind of hard. I would recommend prime factorization because I'm now in the unknown zone. Like, I got to figure out if any number between 7 and 25 go into 175. You need someone? Okay. So I'm going to say let's switch gears real quick and do prime factorization. Because my problem is I got to do 8, 9, 10, 11, all the way up to 25 to see if they go into 175, and that's just hard math. I'm going to show you that prime factorization for this one is a little bit easier. Let's see, 5 times 25, I'm sorry, 5 times 15, 5 is prime, 3 times 5, and I'm done with that. You see how much quicker that one was? Okay, not always that quicker. Let's see, 25 times, what do we say, 7, right? And 25 is 5 times 5. That's pretty darn quick, right? We write the prime factorization, that's 3 times 5 times 5. And this one is 2 5s times 7. For GCF, it's what do they have in common? What do they have in common? 2 5s, so the answer is 25. So can you kind of see how prime factorization is a little bit quicker? Why did I say prime factorization is the one that we don't use that often? You remember from yesterday? You forget how to do this, right? 2 years from now, you're not going to remember this. So although prime factorization is the easiest one, it's elegant, works every time, it's easily forgettable. But oh boy, does it make your life a little bit easier, especially on the big numbers. Smaller numbers, we can use brute force, no issues. But for large numbers, I would recommend prime factorization. We good? All right, let's go over homework. So 2 through 20 evens. Number 2 is 9. Number 4 is 13. Number 6 is 11. Number 8, we just figured it out, it's 25. Number 10 is 27. Number 12 is 1. Those two numbers are relatively prime. Number 14 is 125. Really big numbers. Nathan, don't turn around your seat, please. Number 16 is 132. Number 18, period 1 had problems on that one. 225. We did it by prime factorization. And then number 20 is 9. Number what?
2.
Number 2 was 9. Hey, number 2 and number 20, same answer. Now you got your homework? Did you grade it? Why not? I just called out all the answers. You're supposed to be grading. Yes. Number 6 was 11. All right. Emilius has come around to grab your homework. And Antonio is passing out. Everyone else, look at the board and copy down your homework. Test is on Monday. We'll do a review tomorrow. Notice what the instructions say. The instructions say use the technique of your own choice, meaning I'm going to show you 2 more techniques. You can pick which one you like. Yeah. What's what? What's what? The answer, I don't know. I just closed my book. All right. Turn it in, circle it. I'll check it for you. Why do students have a knack of asking me the question after I close the book? Why do I have the knack of ignoring students? So that's what I will work on.
No, because we're annoying.
Well, not all of you are annoying.
I'm annoying. Am I annoying?
No, we're not going to play that.
Let's play the game.
We're not going to play that game.
That game where you get half.
Right. All right. So I'm going to say for a 3rd time today already. Hey, I'm going to show you something. It's not going to be confusing. The rules are different from yesterday. So why is it in total confusing? It's because we're going to do 2 things, LCM and GCF, that have many similarities. I have all the homework. It's almost like that. If it were opposite, it would be perfect, right? The brute force is not opposite, though. The prime factorization, well, it's kind of sort of opposite. And like I said, the key to doing well on the test for these is just on your resource card, you at least have 1 example. So that when you get the question on the test, you're like, oh, okay, I know what to do. Secondly, I'm going to give you really easy numbers to do. And there's a lot of smart kids in this class. Some of you will be able to do some of this in your head. I'm just going to warn you, on the test and on homework, there are numbers that you cannot do in your head. So even though you may look at this and say, well, why does he teach this hard technique? I already know the answer is whatever, right? We'll do at least 1 hard one for practice at the end of class. But I also don't want to make it impossible for everyone. I want to give you nice friendly numbers so that we can talk about the concept rather than dealing with really challenging math. We'll do a challenging one at the end, but I give you nice, easy, friendly numbers so that you can have a lot of buy-in to the process and make it easy. Ready? Here we go. So not greatest common factor, least common multiple. So instead of doing factors, now we're doing multiples. All right. Multiple methods, the same methods as yesterday, brute force and prime factorization. Except we do brute force slightly different. We do prime factorization slightly different. All right, last class we did GCF by brute force, prime factorization, just a quick review. So to do GCF, greatest common factor, brute force, we write the two numbers. We write every factor of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. We do the same thing for 42. 1 and 42, 2 and 21, 3 and 14, 6 and 7. And we figure out which is the biggest number they have in common. What's the biggest number they have in common? 6. So therefore the answer is 6. That's brute force. We just found in the example that she asked earlier, brute force, when the numbers are really large, isn't that fun? The more elegant way of doing this is prime factorization. Same two questions, 30 and 42. We do the prime factorization of each number. Do this real quick for you. Prime factorization of each number, and then once the prime factorization is done, we choose only what they have in common. They both have a 2 in common, and they both have a, so 2 times 3 is, it's pretty elegant, gets you your answer every single time. Yep, that's what we did yesterday. This ain't what we're doing today. Today, we're doing least common multiple. It's got the same two techniques, brute force, prime factorization, but they're done differently. Hence the confusion. Here we go. Yesterday, don't write this down yet. Yesterday, we did greatest common factor. Remember, we're looking for factors, but today it's called least common multiples. So we need to find, instead of a factor of the two numbers, we need to find a multiple of the two numbers. Write this down, box 1. So to reacquaint you with this word multiple, this is when the math teacher says count by 4s. You're giving me the multiples of 4. Count by 20s. You're giving me the multiples of 20. That's a given number that you count by. If I give you 12, what are the multiples of 12? Somebody.
36, 48.
So what are you really doing there? Well, some people think of this as adding. Some people think of this as multiplying. You take the given number, you multiply by 1, then 2, then 3, then 4. Well, in other words, we're counting by 12 for those that like to think of this as addition. The definition is weird words. It says a number, we're talking about these numbers, 12, 24, 36, a number that a given number is a factor of. It doesn't have the word multiple in the definition. This is also why this becomes confusing. The difference between factor and multiple. Multiple, you're multiplying. Factors, technically you're dividing. What number divides into 12? That's a factor of 12. What's a multiple of 12? Then you're multiplying by 1, 2, 3, 4, so forth and so on. Hey, there are a finite number of factors of any number. The factors of 12 are 1, 2, 3, 4, 6, 12. That's a finite number, Laura. Okay. Multiples of 12, guess how many there are? Infinite. That's a second difference. So our brute force technique of listing all the factors doesn't work with multiples because there's an infinite number of these. Today we'll be finding, box 2, the least common multiple, the smallest multiple of two given numbers. The smallest multiple, it says 2 or more numbers. So I'll give you 2 numbers. You're going to tell me the smallest number that is a common multiple of both of them. The smallest number that is a common multiple of both of them. Least common multiple, the smallest multiple of 2 or more numbers. I'm going to give you 2 numbers. You're going to tell me the smallest number that are multiples of both of them. Anybody know the answer? 12 and 20? What? 2 is a factor, not a multiple.
Oh, well then 60.
60 is the answer. Now, clearly, at least 2 people already know how to do this by brute force, because that's what they just did. They thought about all the multiples of 12, they thought about all the multiples of 20, and they found the smallest one that's in that list. They're doing brute force. Remember yesterday I said, what's the largest number that goes into? The largest number that goes into 12 and 20 is 4. 4 is a factor of both. Now we're not doing factors, we're doing multiples. 60, when we count by 12s, we get to 60. When we count by 20, we get to 60. Multiples are bigger, factors are smaller. Well, almost always. So the greatest common multiple would be infinity, because these numbers go to infinity, right? Multiples never stop. So that's why it can't be the greatest common multiple. It's got to be the least common multiple. It's the smallest common multiple. It's paradoxical, and I understand. I had the same problem when I was your age. Like, why isn't the common factor called the least common factor? Why isn't this one called the greatest common multiple? Because it's just the opposite of that. The least common factor is always 1. Turn around. The greatest common multiple is, the least common multiple is not infinity. Okay, so we have notation just like we did for GCF. The notation is going to have an L, a C, and an M, and it's going to have parentheses and 2 numbers. So tonight for homework, they're going to write it like this. They're saying, give me the least common multiple of 12 and 20. Make sense? We write our answer with an equal sign and whatever that multiple is. Now we'll talk about the 2 techniques. Hey, it's the same 2 techniques as yesterday. Okay? The 2 techniques are brute force and prime factorization. One at a time. One at a time. Stop me if I'm talking too fast, because I am right now. First technique, brute force. It is not elegant. It's sloppy. It's just, I'm just gonna bulldoze my way to the answer. I'm gonna write down every possible answer and see which one it is. Okay? It takes the most time because I'm writing down lots of answers, possible answers. Only one is the answer. And it does always work, though. By the way, it's how they came up with 60 as the answer. They used brute force. It's easy to remember, right? It's also the most commonly used. By the way, why are we doing this? If you remember from yesterday, I said we do greatest common factor when we reduce fractions. This is how we find common denominators. Whatever is going on, it better stop. This is how we find common denominators, is we find least common multiples. I'll give you 2 fractions, 1/2 plus 1/7. You find the common multiple. Hopefully it's the least common multiple. Okay, brute force, here's how it's done, 8 and 12. I said I'm going to give you nice friendly numbers. Here one couldn't wrap their head around it. They're like, well, I already know the answer. I said, yeah, because I'm giving you easy numbers so that we can do a bunch of these. Okay, least common multiple of 8 and 20. Here's the brute force technique. We go to this number, we just list the multiples, count by 8s. Keep going.
20.
8, 16,
20.
24, 30.
It would be 40.
It would be 40.
All right, so we're going to count by 8s. Some of you have already figured out how this works. We're going to count by 8s. How long should we count?
Until 40.
Okay, well, always to 40?
Until we hit a
Okay, so there's usually 2 or 3 types of students. There's the student that can already recognize what to do. There's the student that are like, well, where are they getting that number from? And then maybe they catch on. There's the student that has no idea what's going on. I'm going to teach to that student. For those of you that know what's going on, pat yourself on the back and just keep your mouth closed. Okay? So for those that like, okay, give me a way of doing this, that's what I'm doing. Maddie, right? I want you to write the first 5, not because Maddie is slow kid, right?
I am.
Right? I wouldn't say you were. Give me the first 5 multiples of 8. Tell me what they are. Count by 8s. You just did. You haven't said anything wrong yet. Keep going. You said 24, 2. Next. 40. Okay. So I'm going to recommend, Maddie, and for everyone else, that you're going to write 5 of them down. There's nothing special about 5. It's just that you want a stopping point at some place. So I'm going to recommend write down the first 5 multiples, right? And then what you're going to do, Maddie, is you're going to go to the second number. You paying attention?
Not really.
Now you are. And you're going to count by this number, but you're going to think about these numbers. If you ever get to one of these numbers, you're going to stop. I'll say that again. You're going to count by 20s, but you're going to be thinking about this list that you just wrote down. If you ever get to one of these numbers, stop. Go. And you stop because we got to a number that was on the list. This is called brute force. Okay? Brute force. Now I'll talk about the other two groups of kids. I'm going to start reading those out loud if I continue to see that. Stop right now, or both of you will have detention. Okay. Lost my train of thought. Write down the first 5. Look at the second one. Count by that number until you get to a common number. Oh, smart kids. So smart kids, I'm going to claim this is what you're doing, except that you're doing this. Finish the sentence. You're doing this all in your head. It's not that we're doing it quicker in the sense of you're skipping a step, Nathan. Right? Head up. It's not that you're skipping any step. You're just doing this whole thing in your head, and that's perfectly fine. Okay. But this is brute force. Oh, by the way, it does not work with tonight's homework. You want to know why?
They're bigger.
They're going to give you 167 and 52. What's the answer? See what I mean? So we better have some better techniques. One technique.
They're actually giving us a number.
Oh, yeah. So one technique is called brute force. Brute force is where we write at least 5 or so multiples of the first one. Then we start writing the multiples of the second one. We stop and we get to one that's on the list. Okay? So LCM of 8 and 20 is 40. Let's do them. All right, here we go. Once again, I'm giving you nice, friendly, easy numbers. Tonight, they're going to be more challenging. All right, Nathan, step 1, what do I do? Okay, so I list the 2 numbers, and I go to the first number, and I list 5. Count by 12s, first 5. 12 what?
42. 24.
Oh, thank you.
And 36.
That's 3.
48. 50.
How about 60?
60.
Okay. And it could be 4, it could be 5, it could be 6 of them. The point is you want to have a bunch of these written down so that when you start counting by the second number, you have enough numbers that you can see, well, which one is the common one. Some of you can count by 15, some of you can't. If you can't count by 15, you're going to need to do some multiplication. 1 times 15 is? 2 times 15 is? 3 times?
45.
4 times?
6.
Bing, ding, 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 ding. We got a common number.
This was easier than
I think so. Okay. So the LCM of 12 and 15 is 60. Okay. Yes.
If we already know numbers, if we already know answers,
Well, I'm gonna still claim you didn't magically. I said 12 and 15, and it popped in your head the answer 60. I'm gonna claim this is what you did. You did this in your head, right? Some people can literally count by 12s and think about the second number. Other people got to think of these numbers and then go to the second number. But some of you can absolutely count by either 12 or 15 and keep the track of both of those numbers in your head. That's fine. By the way, that's what most people do, right? Until the numbers become impossibly large, like tonight for homework. Who's got their homework out right now? Give me the 2 of the hard numbers. Give me the LCM of
54 and 180.
54 and 180. Good luck with that, doing that in your head, right? You're going to need a better technique than trying to do it in your head. All right, box 4, here we go. I got to show you this one because this can occasionally happen. All right, so 3 and 7, let's see. Well, the factor pairs of 3 are just 1 and 3, right? I'm sorry, count by 3. I'm sorry, I'm confusing myself. Count by 3s, let's see, that would be 3, 6, 9, 12, 15, right? That would be the first 5. Count by 7s.
7, 14.
Stop. You got to 21 and we're bigger than that number. So what do we got to do?
Count higher on
We got to count higher on this one. All right, count higher.
18, 21.
Oh, then maybe it matches from the first to the second. So we count higher on the first one, we get to 21. So for those of you that will be using brute force, many of you will, this can be more challenging when you didn't get to an answer immediately. You might have to extend the first one, then extend the second one, then extend the first one. It becomes a little bit of a challenge if you want to use brute force. Okay? Questions on brute force? All right, one more, 12 and 16. All right, this is kind of almost getting to where you can't do this in your head. All right, 12 and 16, count by 12s.
12, 24, 36, 48.
We already had that one, so that was nice. Count by 16s.
16, 32.
32, and I got to think.
16, 32, 48.
Oh, 40. Oh, that was easy. So the answer to that is no. And the reason why is that I'm going to show you prime factorization. And you're going to see how easy it is with prime factorization. Like, you won't need a calculator. By the way, if you have the expensive calculator, there's a button to do LCM.
Ooh.
All right.
Mine doesn't.
Okay. So the answer was 48. Questions? All right. There's 2 in front of you, box 6. Please use brute force. If you're doing brute force in your head, that's fine. Right? If not, then you need to write the answers down, or all the multiples, and find the matching numbers. Okay? Anybody lost on what I want you to do? Let's write our final problem. What? Give me some ugly numbers, Caitlin.
Ugly numbers?
Oh yeah, ones that you can't do in your head. 252 and 210. How about that? Okay, that's the last one we'll do. 252 and 210. Clearly, you can't do that in your head. We need a better technique. And brute force would be really challenging with that. By the way, we done? What do you got?
Yes.
First one? Yeah.
18.
First one is 18. If we list the factors of or multiples of 6, that would be 6, 12, 18, 24, 30, 36. And the other one we not. Oh, we're done after the second one. That was pretty easy. How many people did that in their heads? Okay. This is more like when we're doing fractions. You know, 5, 6 plus 2/9. You got to find the common denominator. Oh, it's 18. That's what you're going to be doing. Second one, 9 and 15. All right. Some of you might be able to realize the answer quickly. Others of you may have to write the answers. Let's see. The first 5 or multiples of 9 are 9, 18, 27, 36, 45. And maybe you get to that and you realize that, wait a minute, 15 is a fact, or sorry, 45 is a multiple of 15. Okay. If not, then you're writing out the multiples. Hey, remember, on any test or quiz I allow, that also I allow hopefully, multiplication table. Guess what's on multiplication tables? The multiples of all the first 12 numbers. Hey, if you got a really good one, maybe it goes up to 25. So I'm just going to say, for those of you that are weak on your math facts, Maddie, right? I'm going to highly recommend, and it's not just Maddie, right? I'm just saying I'm going to highly recommend having a multiplication table, but it does not count as a resource card. It's an addition to it, right? What I won't allow is a calculator, right? Okay, so we've seen how this works with brute force. Now I'm going to use the same numbers, but we're going to use the second technique. And we'll end up doing this one on the board over here, 252 and 210. All right, bless you, now hand sanitizer.
That's how bullet gets ice.
Anybody have a dog who does that?
That's my dog. My dog is every day.
Or is that you sticking your head on the thing?
That's me and my dog.
I used to get in trouble from my mom because I would spray the water.
Oh, I love doing that.
All right, here we go. Second technique. Hey, I'm going to claim that brute force for these numbers is really hard, right? It can be done, right? But boy, does it take a lot of work. The second technique, prime factorization, makes this pretty easy. All right, here we go. Prime factorization is second technique. It's not like what we did yesterday, except the prime factorization part. It's still prime factorization. It's what you do with the two answers. So you paying attention?
Yeah.
All right, prime factorization is elegant, meaning it's nice and sweet and cool. It's certainly easier a little bit. It always works as well. It's the hardest to remember, like, what are the rules, okay? Which is why most people don't use this. But when you have weird numbers like this, you're either reaching for your calculator or you're trying to remember this class right here. All right, here's how it's done. Here's how it's done. We already did this one, 8 and 20. The answer is, what was it? 8 and 20. The answer is 40, right? Okay. So here's how it works. Prime factorization. Well, take a wild guess of what the first thing we're going to do.
I don't know. Write the numbers.
Okay, I wrote the numbers. Now we're going to,
Draw.
it's called prime factorization. So guess what we're going to do?
Find the prime numbers.
We're going to do prime factorization, right? So let's do prime factorization. All right, go for it. Prime factorization.
4
8
and
is
2.
4 and 2. 2 is prime, 4 is not.
2 and 2.
2 and 2. So the prime factorization of 8 is
2 to the 3rd.
2 to the 3rd, or 2 times 2 times 2. We good? All right, Alora, prime factorization, do it.
2 and 10.
2 and 10, sounds good. And then 10 is 2 and 5. So the prime factorization of 20 is 225, right? Or 2 squared times 5. Okay. Hey, that's what we did last night for GCF. For GCF, we pick what's in common. Take a guess what we're going to do now.
We're probably going to multiply them.
The opposite would be what's not in common. No, that's not what we do. Yeah, this is why I'm saying people forget this, because it's hard to, it doesn't make sense. Here's the rule. I want everything. I want it all. So you're going to write everything. Right? You're going to choose everything. Hey, there's 2's and there's 2's. I want it all. You're going to choose the one that has not the least, but the largest number of 2's. Which one has the largest number of 2's?
The first one.
So how many 2's do I want?
3.
Okay. This one has a 5. This one doesn't. I want it. I want everything. And I want the largest of the 2. Well, this one doesn't have 5, so I want 5. My claim is that's 40.
No, it is.
2 times 2?
4.
8,
5.
5. No.
It's 5. What?
Say again?
5.
Who said, what, did you follow the steps?
Well, I know, I know how to do prime factorization, but after we do that,
So we probably need to see some more examples. Okay? Yes? Not until we're done. All right. Box 7, let's do this together. We already know the answer to this one is, because we did it already,
60.
60, right? So let's see how it works with prime factorization. All right, Alora tore through that prime factorization. Are you guys as good as her?
no.
No.
All right, Madison, 12, prime factorization. 6 and 2. 3 and 2. Well, you did it just as quickly as she did it. So 2 times 2 times 3. 2 times 2 times 3. What are you doing?
Stealing your pencil.
Yeah.
Oh,
I'm borrowing it while she's gone.
got it. All right. Who are we on? Antonio, 15. Give me prime factorization.
3 and 15.
3 and 3 and 5. And both of those are prime. That was easy. Okay. So the hard part of the rule is it tells you to give me everything. So this is what Danny said. I'm confused. So by everything, I mean, I want it all. Hey, this one has a 2. Does this one have a 2? I want it. But how many 2's are here?
2.
So you pick all of them. Give me all the 2's. So how many 2's would that be, Danny?
2.
Okay. This one has a 3. This one doesn't. I want it. This one has a 5. This one doesn't. I want it. I want it all.
That one does have a 3.
So I took it, right?
Wait, they both have it.
So I took it.
But what about, why do you not?
So you basically just take everything.
I take everything.
You just add
If there's something common, I choose the larger of the 2. Notice this time they both had 1, 3, so it's 1, 3. I want it all. Yeah, and that's the point we got to make. You're going to look at both lists. You're going to pick every number that you see. But when there's duplicates, you pick the one that's the largest. Like if there's 2 3's on this side and 5 3's on this side, you choose 5 3's. If one on each, that's the same number. You just choose one. I think we need to do one more and then Danny will be happy. Oh, by the way, I'm going to claim this is 60. 2 times 2
4,
times 3
12,
times 5
60.
is 60. Okay. All right, Danny's still not convinced. She's got to see another one. All right, we already did this one, Danny. What was the answer? What did we say the greatest common or
21.
least common multiple we said was 21? Okay, so let's see. Prime factorization. Well, 3 is already prime. So 7. They're relatively prime to each other because they're both prime. I mean, I guess I could write 3 as 1 times 3, but 1 isn't prime, but 3 is prime. I guess I could write 7 as 1 times 7 if I wanted to. I wouldn't do that, by the way. 7 is prime. So my prime factorization is 3 and 7. I want it all. So guess what I'm going to pick? Here's the answer, 3 and 7. I want it all. So what am I going to pick? I'm going to pick them all. I'm going to pick 3 and 7. I'm choosing everything. Because 1's not prime. 1's not even composite. I said I wasn't really doing prime factorization here, but for those of you that needed to see something, well, 1 times 7 is 7. Yeah, it would still come out as 21. Good call. Okay. Yes, let's do one more. Danny's almost convinced. 12 and 16. What was the answer, by the way?
48.
48. So we know the answer is 48. All right, so let's do this. Here we go. 12 and 16. Prime factorization. Danny, 12. Keep talking. We don't need to do it for 2. We've already circled 2. We're going to do the 6. 2 and 3. So prime factorization of 12 is 2, 2, 3. 2 times 2 times 3. 16, I'll do it. 2 times 8. 2 times 4. 2 times 2. So 2, 2, 2, 2. So this is a very good example of what to do. You ready? You see the 2 prime factorizations in light blue? I want it all. I got 2's over here. I got 2's over here. I want the biggest one. Which one is the biggest one?
4.
The one that has 4. So I'm going to write, Danny, I want the biggest one of the 2, pun intended. So I choose the 4. Well, this one has a 3. This one does. I want it all, so I want a 3. So I want these 4 2's and that 3. I don't choose these 2 2's because there's more over here. There's 4 of them. I want it all. Okay? So it's 4 2's and a 3. I'm going to claim that that's, what was the answer, 48? Is that right?
48.
All right, let's see. 2 times 2
4.
times 2
8.
times 2.
16.
And it turns out that 16 times 3 is 48. That's prime factorization. Now, granted, I think many of you would say that, wait a minute, I could have gotten to 48 using brute force quicker. True, but not on that one. So let's do that one.
I already got the answer.
Okay, here we go. I'm going to claim that prime factorization makes it easier. 2 and 252 would be 2 times 120. 126, I believe. Is that right? 126? Yeah, 126. Okay, so that's prime. 126 would be 2 and 60. 63. What goes into 63? 3. So that would be 3 and 20. 21. And 21 is, well, that wasn't, I mean, didn't take us long at all. So let's see, we got 1, 2 2's. So I got 2 2's. I got 2 3's and a 7. Prime factorization. 210. 2 and 105. What goes into 105?
2.
2 doesn't go to 105.
Of course,
How about 5, right?
5 and
5
21.
and 21.
5 and 21.
3 and 7.
3 and 7. So I think you can see that we're almost to the answer, and it didn't take that long. Prime factorization kicks butt on these ugly ones. Hint, hint tonight for homework. So we got 1, 2, 1, 3, 1, 5, 1, 7. So here in box form are what we need to look at. I want it all, Danny. I got a 2. I got a 2. Which one has the most 2s? So how many 2s do I want?
2.
I want 2 2s. There's your final answer. I got 2 3s and I got 1 3. I want it all, so I want 2 3s. I want the 5, and I want the 7. These are 7 1. And my claim is that when you multiply all of that together, that's the end. Okay, not, you got to do a little bit of work. 2 times 2 is times 3 times 3. All right, now we need to do some work. 36 times 5. Or she wants to do it one step. 5 times 7 is 35. So 36 times 35. 5 times 6 is 30. Carry 3. 5 times 3 is 15. Plus 3 is 18. Bring down to 0. 3 times 6 is 18. Carry 1. 3 times 3 is 9. Plus 1 is 10. I'm going to claim the answer is 1,260. So who's got the expensive calculator? Pull your calculator out. Hit catalog. Scroll down to LCM, because this calculator has that button. It has a couple hundred buttons. I'm scrolling down through all the buttons right now because there's that many buttons. LCM, I want you to hit 252, comma, 210 and hit enter. 252, comma, and then 210, and hit enter. What do you got? What's it say?
Did you hit the wrong button or something?
What did you do?
No, yeah, I did exactly what you said. It's just like
What? He's got the answer. What's it say?
1,260.
1,260. You hit some weird button. All right. Hey. Clearly something back there is going on. I'm not sure if you paid any attention to the class, right? You need to ask questions. Tonight for homework, there's at least 4, maybe 5 of them that are not necessarily that ugly, but they're pretty darn ugly.
Is there any
Right?
bigger?
What does it say?
No, there's no bigger than that.
Yeah, but I'm saying, what's the biggest number they have?
196.
196.
To 56.
And then to 56. You need to use prime factorization for that one. Unless you literally want to count by 196s, right? So your choices are either prime factorization or brute force. So Danny, can you do brute force? So you'll be fine if you want to use brute force. It just will take you a little bit more time. Prime factorization makes your life a little easier, right? And it makes it really easy when the numbers are really large. Hey, prime factorization when the number is 2 and 8 doesn't make your life any easier. It's longer. Hey, what is the LCM of 2 and 8? What's the LCM of 2 and 8?
Oh, 16.
Count by 2s.
16. 8.
Now count by 8s. What's the first number?
8.
What's the first number if you count by 8? So what's the LCM of 2 and 8?
8.
See what I mean? So listen, please. Listen. So I switch back and forth between prime factorization and brute force. If it says the LCM of 2 and 8, I'm not doing prime factorization. It would take me too long. I'm going to count by 2s. Oh, wait, it's 8. And I'm done. But on 252 and 210, I'm going to use prime factorization. My belief is you just need to do a few of these practice and you'll be okay. Make sure, come student advisement, right? If you're still a little bit weak on prime factorization, let me help you, okay? All right, any other questions? Oh, by the way, we already knew these answers because we already did them, but for those that were trying to do prime factorization last time, Danny, okay, here is the prime factorization of both of these. I got 2s, I want my 2. I got 3s, I don't want the 1 3, I want both of them on this one. I want the largest. So it'd be 2 times 3 times 3. On this one right here, I got 2 3s and a 3 and a 5. I want all the 3s on one of them, and I want this 5. So 3 times 3 times 5. That would be prime factorization. Okay? That gives me what? 18, and this gives me 45. Is that right? Yeah. So 18 and 45. That was it. What? Can we go home?
Early.
Yeah, let's all just go home.
Yeah.
I can do it one time.
tomorrow?
I mean, obviously I'd get fired, but I can do it one time, right?
Yes.
So the question is, do I want to get fired today?
No.
No.
Yes. He won't be our teacher.
I wouldn't be your teacher after today.
Because he's our favorite teacher.
All right. So that's the whole class. What have we got? We got 4 minutes left. All right. No, we left early yesterday. So chit chat lightly, and if you're talking about what you guys are in trouble for, stop it. Okay. I'm just being proactive. I'm being proactive. All right. Eleanor, questions?
Nope, no questions.
Sweet. Catch you tomorrow, Eleanor.
Okay, bye.
All right.